All right, so in this video, we're going to talk about one more triangle and how that is going to allow us to figure out all the other points on the unit circle. We're going to save how to figure out all those points on the unit circle for another video, but I want to talk about the triangle and kind of build you up into that concept. There are three important values that allow you to figure out all of the points on a unit circle. One of them is 1/2. The other one is square root 2 over 2, and then the last one is square root 3 over 2. And you can also notice the pattern here. I'm going square root 1, square root 2, square root 3. In other words, it's like that. You're just jumping up by 1. All the denominators are the same. You can kind of think of it as a pattern, but I think it's just important to know it's 1/2 square root 2 square root 3 over 2. You'll have those memorized. You use them so much with this stuff anyways. We already talked about this value right here. We said this was sine of 45 degrees. In other words, that was cosine of 45 degrees. So we said this right here is equal to that. The other important thing is I wrote these out in a specific order. The order, which these all are labeled, are from least to greatest. So this is my smallest value, and this value is my largest. And this is the middle one. So we have those. And I'm going to and I don't expect you to necessarily follow along with this, but I'm just going to show you what I mean by this. Sine always starts at 0. So sine of 0 is 0. The sine of 30 is going to be 1/2. The sine of 45, well, we already talked about that. That's square root 2 over 2. And then the sine of 60 degrees is going to be square root 3 over 2. Cosine of 60 degrees is equal to, it's 1/2. Cosine of 30 degrees is going to be equal to square root 3 over 2, and so on and so forth. You're going to be able to know those just like that using this concept right here, and also kind of picturing these triangles in your head. This will always be the longest side, okay? So I'm going to go over that triangle as to try and get you to understand what this concept to allow you to do stuff like this. So what the idea is to figure out what the sine of 30 degrees is and all that other stuff, all these other values, is you want to consider drawing a triangle, a 30, 60, 90 triangle. There are two main types of triangles. There's the 45, 45, 90, which we already talked about, and then there's the 30, 60, 90 triangle. Now, the way I'm going to draw this is not by drawing the 30, 60, 90. I'm actually going to represent it a little bit differently, okay? What I'm going to do is, in fact, I'm going to take this. I'm going to go like this with it. So this I'm going to call is 60 degrees. And this I'm going to call 60 degrees. And this would be 60 degrees up top. It should probably be a little more, it's an equilateral, it's a little bit squished, but you'll get the idea. So if this is 60 degrees, what I'm going to do is I'm going to go down and break that up. So I'm going to split that thing in half. Now this is going to be my midpoint. And I'm going to say that I can make this length as long as I want. I'm going to make this thing 1. So this also must be 1 here. Now, when I split this thing in half, this whole length right here was originally 1 as well. So now if I split it in half, this length right here would be 1/2. If I'm just looking from there to there. And also for this value here to here, that would also be 1/2. So right away you can see that the cosine of 60 is 1/2 from this triangle right here. Now if I take this value and I split this thing in half, so it's here and here, and you also notice there's this side here and there's this side here, and there's this shared side in the middle. What you see is by SSS and CPCTC that this angle and this angle must be the same. So this means that this value, when I split it right in half, that this must be 30 degrees over here. From here to here, that would be 30. And from this angle right here is 30 degrees as well. Now, so we figured out, if we're looking at just this right triangle over here, that we have our half and our 1 right here. So I'm going to erase this left triangle because it's useless now, and I'm just going to look at the right part of it. You also can figure out that this right here is 90 degrees by using CPCTC as well. And this is why we get ourselves the 30, 60, 90 triangle. And if you didn't understand why that is 90, it's because this would be x and this would be x. They must add up to 180. So you get 2x is equal to 180, so x would be 90, so that must be 90. But what's important is that we have this 30, 60, 90 degree triangle on our hands. And this is 1/2. If we are wanting to figure out what this side would be, what we can do is we can use the Pythagorean theorem, and we can just call that side x. So what you have is x squared plus 1/2 squared, you need the parentheses around it, is equal to my hypotenuse squared. In other words, x squared is equal to 1 squared minus 1/2 squared. This implies, it's not an equal sign, that implies that x squared is equal to, and then you have 1 squared, so that's going to be 4 over 4. The reason I'm doing this in one step is to find a common denominator. 1/2 times 1/2 is minus 1 over 4. So I get something looking like that. So x squared is equal to 4 minus 1 is 3 over 4. So x, we take the square root of both sides. Again, we don't want the negative value. X is not negative here. It's a positive distance, so I can ignore the negative case. So x is going to be equal to the square root of 3 over 4. And in other words, I can break this up into square root 3 over square root 4. So x will be equal to square root 3 over square root 4 is the same thing as saying square root 3 over 2. So we can take x and plug it back in over here. X is no longer x. We can just call this number square root 3 over 2. So that's what x would be equal to. And so what we see here is that along this 30-degree angle, that this side connected to it is always going to be the longest side. So the side connected to the 30-degree angle is the biggest. The side connected to the 60-degree is the smallest. It's the half one. And then the 45-45 case is the square root 2 over 2 term. So in context to the circle, so I'm going to erase this right here. In context to the circle, we can use this triangle to figure out all the other values. So like if we have this case where it's 30 degrees, you know that this would be 60 and this would be 90. That if the unit circle has a radius of 1, that the longest side, the side connected to the 30 degrees. Now, when you draw this too, way I kind of think of it is that if you draw a triangle and it's going to be 30 degrees, so it's kind of smushed this way almost. When it's 30 degrees out here, this side is going to be, it's like it's smushed down, so it's going to be longer. This side is the longest side over here. So I'm going to represent that as square root 3 over 2. And then over here, this would be 1/2, because this is the side connected to the 60 degree term. So the longer side, this would be longer. And this would be the shorter side. And we can see here that this would be the x-coordinate. If this was a unit circle with a radius of 1, that this would be the x-coordinate. So this would be cosine of 30 degrees would be equal to square root 3 over 2. And we also can figure out that, the sine terms as well. But I want to show you now how the lengths kind of relate to these things. We talked about the 30, 60, 90 triangle. Square root 3 over 2 and 1/2 are the two other values. I'm just going to focus in on the first quadrant for the rest of this video. If we look at our circle, so our circle kind of looks like this. Okay, we know that this value right here is 1, 0. And we know that this value right here will be 0, 1. This is a unit circle. This is at 0 degrees. This is at 90 degrees. If we look at the 30 degree, so 30 degrees is over here. When it's 30 degrees, you know that this would be 60. When you look at the 30 degree one, you see that the x-coordinate is going to be the longer side. And I always think the x-coordinate is my cosine term. It's the longer side. The longer one was the square root 3 over 2 term. So for this point, the x-coordinate is going to be square root 3 over 2. And then by default, the other one is going to be the other length. So it's going to be 1/2. If we move up to, so this would be for 30 degrees out here. So if we go up to the 45 degree term, so this would be 30 degrees out here. If you look to the 45 degree term, you know that, I'm going to write 45 over here, that they're the same, so it's square root 2 over 2 and square root 2 over 2. So at 45 degrees, you have this cosine and sine being the same, which would be at 0 degrees. And then once you get up to here, so you're going way up top, this triangle's opening up a lot more, so it's at 60 degrees now. Notice that this side is going to be smaller. This is the way I do it. This is the way I've always kind of thought of it, is that when this angle becomes 60 degrees, this side becomes super small over here. So it's going to be the smaller value for cosine. So this would be my 1/2 term. And by default, that would mean that my sine term would be square root 3 over 2. You can see that my y-coordinate is longer, but the way I always think about it is in terms of cosine right away. This cosine term is small here. It's almost 0. It's smaller here, this length is. So it's my half value. And this would be at my 60-degree mark right here. Okay, so, and as you can see here, sine of 0 is going to give me 0. Sine of 30 degrees is going to give me 1/2. Sine of 45 is square root 2 over 2. And sine of 60 is square root 3 over 2. Sine of 90 is going to be 1. So this would be 90 degrees over here. Cosine of 0 would be 1. Cosine of 30 would be square root 3 over 2. Cosine of 45 is square root 2 over 2. And cosine of 60 is 1/2. Lastly, cosine of 90 degrees would give me 0. So we can kind of picture this triangle in our head to figure out the first quadrant. And we're going to keep going with this hopefully soon. All right.